So, good evening. This is part two. Let's actually just pray first. Father, I thank you for this time we can take on a Sunday evening and have part two of this series and on asteroids, comets, TNOs, Lord. And I just pray that you would be glorified and that you would help us to understand truth. And Lord, if there's anything that we don't understand about this, that you would help us. And we just want to desire to have you lead us, God. And we thank you for Brian Nickel, who put this together, a lot of what we're going to be seeing tonight. And I pray that you would be glorified. In Jesus' name, amen. So, for those that are, is there anybody just joining us this week, wasn't here last week? Okay, well, then the lead-in is what we're doing is a two-part series on asteroids, comets, TNOs. Where do they come from? Biblically, last week I did a PowerPoint presentation that gave all the evidence in space by probes that have gone to asteroids, probes that have gone to comets, brought back information to Earth that can't be explained by evolutionists' theories, but can be perfectly explained and only explained by the hydroplate theory. Other creationists that reject the hydroplate theory, they say that asteroids, comets were part of the creation, which has a problem. And we talked about all that last week for 2 hours. And then backing up a little bit more, the reason for doing this is because on December 8th of 2022, a month ago, a little more than a month ago, I was invited by Dr. Randy Galusa, who is the current CEO of ICR, to come and teach all the scientists that are on staff there at their headquarters in Dallas, Texas, to do this presentation. The whole thing took a little over 4 hours. And that presentation was everything that I did last week, almost exactly everything that I did last week. And then this week is going to be the same thing, except we're going to watch a little bit more of Brian Nickel. And so we'll explain that as I lead into this. But so Dr. Randy Galusa and Rob Yardley, a board member of ICR, Mike Snavely, who runs Mission Imperative, Juanita was there as well with me, and Brian Nickel was zooming in, and Rob Brown, who is an aeronautics professor at the Air Force Academy, was zooming in, and they were my proof checks, they're my fact checkers, so that they were there, and I told them up front, if I'm saying anything about the evidence that's out of line, and neither one of those guys chimed in and said, Kevin, you're wrong. So everything that was backed up by professional, an engineer. Brian Nickel is a mechanical engineer, and Rob Brown knows about space. He knows about all these things that they're finding, and he is a hydroplate theory advocate that works at the Air Force Academy. He's now a tenured professor, and so he says he's coming out a little bit more as a result of that about what his views on the hydroplate theory. And there was also Jim McDowell, who was going to be Jim McDowell was there, who is going to be co-publishing with Mike Snavely of Mission Imperative the 9th edition of Dr. Brown's book, which is not available quite yet, but getting very close. And then all the ICR scientists are all doctorates in their fields. And then I wanted to say something as a correction of last week, but actually we're going to cut and paste it in and make it so I didn't even say anything wrong. But when I emphasized last week that the difference between comets and asteroids, the difference between comets and asteroids are twofold. Comets have like water or other volatiles. They can have liquid nitrogen and liquid oxygen that become the volatiles that act as a Carnot engine to accelerate them out when they're coming close to the sun, and they get their liquid nitrogen or solid frozen nitrogen or oxygen can come back, and when it gets close to the sun, even carbon dioxide, they come back close to the sun, and then it volatilizes it, and that's what gives it the tail. And there are highly elliptical orbits as well. So the difference is asteroids don't have volatiles on them, so you don't see the tails, comet tails and stuff, which is from pushing out debris and dust from the object, the head of the comet. And so comets were launched with more energy from the Earth. When debris was being launched, the ones that really got a tremendous acceleration, they went into highly elliptical orbits that are the comets. So those are the two differences, not just that one has volatiles and one does not. So wanted to emphasize that. And also had a question from last week that you were talking about all this stuff went up and some came down. So how did Noah and his family survive in an ark where the Earth is getting pummeled all the time? Which is a very good question. And the answer is, God told him to build a roof. And he might have even said, make it really thick. And so that it would have taken some of the smaller debris, and God had to have protected them from the big debris that was coming down. So he just made sure that none of the big debris hit the ark. That's a very good question. People come up with that, and that's very applicable. So what happened back on December 8th is Randy says, okay, we get it. That's where they came from. So let's hear some more of because I wanted to go straight to Brian Nichols' animations, PowerPoint animations for exactly how the physics and mechanics behind debris that goes into space turning into comets and asteroids. And he goes, skip that. We just want to know other parts of the hydroplate theory. So I'm going to show you this because my goal for this two-part series is we'll post it on YouTube, and if people ask, what did you tell the ICR people, I'm going to say, go to our YouTube and watch part 1, part 2. You're going to see what they saw. So we're now going to go away from comets and asteroids into, and what Brian says is, Kevin, everybody in the room agrees with what I said for the first 15 minutes. And so then just go on part 1, his very first one, he says, go from 15 minutes on, which we're going to do. And it's going to be actually 14:07 on, because that's when it's hard to find 15. And then we're going to watch this, which is part 1. And I want to emphasize for those that are just watching this, how do I get to Brian Nichols' website? His name is Bryan, instead of regular Brian. Bryan, nickel, like a nickel. And you go to YouTube, Brian Nichol Hydroplate Theory, and then you'll see his channel presented on the top. You click on his channel, and then you click on videos, and you'll see all the different videos that he has pertaining to the hydroplate theory. So that's the background to tonight. And so what we're going to do is watch 15 minutes till the end of this first one. And the first one, his part 1 is for 31 minutes. So we're going to basically watch 15 minutes of 60 minutes of part 1, which is from 15 to the end. Then what we did at ICR is we watched part 2 until it got into comets and asteroids. And Randy says, we don't want to watch that. We've already seen that. And we were at about 4.5 hours at that point. So 4 hours and some change. So then that's what stopped it. We're going to keep watching part 2. And then we're going to watch his part on the comets and asteroids, which is like 40 minutes, 30, 40 minutes. Okay? That's the plan for tonight.
Supposedly 4.5 billion years ago, asteroids gravitationally collapsed into each other, and the energy released from these impacts produced a molten liquid Earth, which remained molten for millions of years. As accretion ceased, the surface eventually cooled and formed a solid crust, but as we just covered, a granite crust could not have originated from a previously molten condition, and no lab has ever been able to replicate granite from a molten state. The evolutionary model then states that over time, the remaining inner molten materials were gravitationally separated to form the dense solid inner and outer cores of the Earth. Note that any thermal analysis accounting for all realistic forms of heat generation and heat transfer predicts that the sphere of Earth should have completely solidified by now if it is actually 4.5 billion years old. This is one of many observations which strongly indicate the upper limit of Earth's age is much younger than assumed when relying on radiometric ratios. To further investigate the fundamental problems with radiometric dating, please refer to my other video titled Hydroplate Theory: The Origin of Earth's Radioactivity. Evolutionary theory of the Earth's origin assumes that the Earth remained in a molten state for around 200 million years. Naturally, any water brought by asteroids would rise to the surface and evaporate long before the Earth's crust solidified. A runaway greenhouse would have followed, trapping solar heat in the humid atmosphere and making life on Earth impossible forever. According to some evolutionists, millions of years after surface solidification, comets bombarded the Earth, depositing even more water on its surface. But recent discoveries of high deuterium concentration, or heavy water, on comets, compared to Earth's oceans, have led some scientists to conclude that Earth's water could not have come from comets. In summary, the evolutionary theories of how water came to be so prevalent on Earth's surface is not supported by what we observe today. But if we assume the evolutionary theory is somehow true, then basic scientific principles tell us that Earth's water should only be found on the surface. What is surprising from this evolutionary view is that there are unexpectedly large amounts of water trapped at depths far deeper than surface water could ever seep. Here is why deep water under continents is not expected. Imagine a block of soft modeling clay or Play-Doh. Now stack more blocks of clay on top. Eventually, the bottom block will deform sideways due to the weight of the added blocks. Add more blocks and more of the material deforms. Now imagine that you have stacked another column of clay blocks very close to the original column. What will it do? It too will deform and compress against the other material. The dashed line represents the boundary at which the compressive strength of the clay or Play-Doh has been exceeded. Material below this boundary forms a tight seal. Even small microscopic cracks cannot exist below this boundary line. Take notice that gravity is the causal source of this condition. Even if surface water is poured into the gap or crack, it cannot seep below the boundary line. For clay or Play-Doh, this boundary may be only a few feet from the surface. You've likely seen a similar scenario after making stovetop pudding or cheesecake, after it cools in the refrigerator overnight. The semi-solid separates or cracks at the surface as it cools, but the crack is not very deep because the weight of the material slumps and closes the crack at a certain depth. Rock like granite has good compressive strength and can support a crack of up to 5 miles depth, but no deeper. In summary, assuming the evolution scenario, water from asteroids and comets collected on the surface before crust solidification, since granite's max compressive strength is approximately 23,000 pounds per square inch. No significant continental water would be expected below 5 miles depth. However, it is well known that deep water exists much deeper than this. Germany's KTB dig and Russia's Kola dig are the deepest man-made holes in Earth's crystalline continental granite. The goal of these digs was to reach the Earth's mantle rock, but neither succeeded. Both holes reached depths well below the 5-mile boundary of granite's max compressive strength. Both holes encountered unexpectedly extreme heat as depth increased. Even more surprisingly, they both struck saltwater-filled interconnected fractures in the granite. More recently, using conductivity measurements, a mile-thick layer of saltwater-filled sediments has been reported 10 miles under the Tibetan Plateau. In fact, deep saltwater appears to be a common trait under all continents. Hydroplate theory asks the question, if evolution theory does not predict deep water, then how else did the water get so deep under all the continents? At this point, it is interesting to note that the Bible indicates in several places that water was and is under the earth. Psalms repeatedly indicates this. The deep is in storehouses. The earth is founded upon the seas and upon the waters. The earth is spread out above the waters. Finally, and most telling, is the opening action of the flood recorded in Genesis 7 verse 11. The Bible strongly indicates large amounts of water were originally deep under the earth. The hydroplate theory uses these biblical descriptions in combination with many real-world observations we've just covered to derive its starting assumption about the original layout of Earth, which is radically different than what we see today, and certainly much different than what uniformitarian theory proposes. The assumed condition is that the Earth's surface crust was formed above a deep layer of water. This is a global condition wherein the Earth crust was an unbroken spherical supercontinent which covered and sealed in a deep layer of water trapped between it and the mantle rock. Many imagine that a combination of forces like the tidal pull of the moon, Coriolis forces, and centrifugal forces would somehow rip this shell apart immediately, and therefore hydroplate theory is invalid from its first assumption. However, few can maintain such a view once they compare all these forces to the dominating gravitational force of Earth. Although other forces are present, they can often be ignored because they are so small compared to gravity. There is a reason gravity is the first force we learn of in school. As we discuss the hydroplate theory's many observations, take note of how so much of the theory's explanation is simply founded upon the physics of what happens to materials under the influence of Earth's gravity. Rather than speculation about unconfirmed natural processes or imagined miracles, we'll see hydroplate theory turn again and again to Earth's gravity as the causal mechanism which drove processes and produced various effects. The Bible records further detail of these assumed starting conditions in the creation account of Genesis 1. The Hebrew for waters here is mayim, which is always used to describe liquid water. Many attempt to explain waters in verse 2 as if it is a frozen or gaseous vapor in space, but Hebrew does not use mayim to describe those states of water. Hebrew has many other words to describe ice, clouds, and vapor states, so clearly liquid water is in view. Then on the second day of creation, God said, "Let there be an expanse in the midst of the waters, and let it separate the waters from the waters." The word rakia comes from the root word raka, meaning to spread, beat, or hammer out as with a metal. It can also mean a plate. The Septuagint translates rakia with stereoma, meaning a solid, firm structure. The Latin Vulgate uses the term firmamentum, from which the King James translators coined the term firmament. The implication is that the expanse was a solid, firm material. Again, mayim is used in verse 6, so day 2 seems to describe a state where liquid waters from Genesis 1 verse 2 were divided in half and separated by a solid plate of material. Remember I said granite is an enigma and has never been replicated. Hydroplate theory proposes that this expanse material was a miraculous formation of a granite crust separating surface water from the waters of the deep. On the third day, Genesis 1 describes the results of God's further direction to firmly position the somewhat unstable expanse and bring it to a more stable equilibrium. Hydroplate theory proposes that the granite expanse was deformed at many points around the Earth, which settled into the solid mantle foundation below. Naturally, the thicker and denser portions of the crust would sink to the solid mantle foundation, but because the volume of water trapped below the crust was fixed, the lighter and less dense portions of the crust had to rise out of the water. This is exactly what Genesis 1 verse 9 describes when God says, "Let the dry land appear." The deformations raised the topography at the surface for dry land, and the depressions gathered surface waters producing small seas. Again, Psalm seems to add further description that matches with this concept. Psalm 75:3, "It is I who have firmly set its pillars." Remember Psalm 33:7 said that God laid up the deep in storehouses. It is important to note that the pillars themselves did not support the entire weight of the crust. Most of the weight was supported by the pressurized water of the deep. With much of the water trapped under the crust, Earth would have had much more available landmass with many small shallow seas dotting the surface. Mountains would have been smaller than today. Hydroplate theory figures that approximately half of the water in today's oceans started out under the granite shelf, forming one giant supercontinent all around the globe. This estimate of the volume of water under the crust is based on the concentration of salt in the oceans today compared to what was found in the Bavarian KTP dig hole. In addition, water found in comets contains around twice the deuterium concentration that is in the oceans. The estimate also assumes that pre-flood seas were fresh water, which after the flood mixed about equal parts with this super salty deuterium-rich subterranean water, diluting it to the levels measured in the oceans today. I will describe more about the most likely origin of comets later, so hold on to this info, as I'm sure at this point it seems strange that water and comets would have anything to do with the flood or with the Earth. Hydroplate does not place an upper bound on the original volume of water in the chamber because there are some unknowns that have a large effect on the final answer. Today we know there are large amounts of water trapped deep in the porous Mohorovičić boundary layers, but we don't know by volume how much is down there. We also don't know how much water escaped Earth's atmosphere during the flood. Both of these unknown variables would add to the volume estimate based on the above concentrations of deuterium and salt. So for now, we'll just say the deep, or the Great Deep as referred to in Genesis 7:11, was a global interconnected subcrustal ocean chamber that was at least 0.9 miles deep at the time of the flood. Based on observations of current size and thickness of continents, hydroplate theory proposes that the original granite plate was 60 miles thick. If you've read prior editions of the theory, you'll notice that this is increased from initial estimates of 10 miles thickness. This change was arrived at after carefully considering the implications of several rather recent discoveries. Most recently in New Zealand, researchers have used explosives to generate specific short wavelength seismic waves to produce the clearest picture of what they believe to be a subducting plate. They are puzzled, however, because almost 50 miles down, a 6-mile thick channel containing melted rock and/or water has also been identified. This is not at all what popular plate tectonic theory predicts. For hydroplate theory, these discoveries are exciting because they are consistent with how a collapsed water-permeated subterranean chamber would be expected to reflect these seismic waves. The much slower wave velocities measured in the channel indicate magma and/or water trapped within the chamber's roof and floor. We will soon cover in detail how hydroplate theory explains these findings using cause-to-effect reasoning. This is the first strong evidence that the granite crust was in fact much thicker than previous estimates. Corroborating this is the growing body of evidence that Trans-Neptunian Objects, or TNOs, are most likely from Earth as well. We'll discuss this further later on. For now, we'll continue discussing the assumed initial pre-flood conditions. Remember, no cracks can exist in granite below 5 miles, so the perfect seal conditions we just reviewed existed to keep the surface waters from seeping down and, more importantly, the subsurface waters of the deep from pushing up through the granite. These are the basic starting assumptions of the hydroplate theory. From here, the theory uses only laws of physics to explain cause to effect, which we'll see provides reasonable and straightforward explanation of Earth's surface features today. This is a phase diagram for water. At atmospheric conditions, we see water freeze at 32 degrees Fahrenheit, 14.7 pounds per square inch pressure. As heat is added, ice melts and the temperature rises until at 212 degrees Fahrenheit, boiling produces vapor. The weight of 60 miles of granite above means that the Great Deep was pressurized to approximately 372,000 pounds per square inch. As will be seen, work was being done on the water of the Great Deep, which gradually increased its internal energy, so we will refer back to this diagram several times and see how conditions in the water changed and the dramatic effects that were produced. Just as the moon's gravity works to produce the ocean tides, the original granite shell would also have been worked and distorted by the moon's gravity. However, because it was a solid shell of great mass, the tidal effect on the crust was not as dramatic as with the open sea. Still, the crust would have deformed into a slight egg shape toward the moon. Obviously, the graphic has been exaggerated so we can see the distortions, and I've simplified the pillars to only 4 dark brown shapes, where the granite was pressed into the solid mantle. In reality, the global surface area of the relatively thin 60-mile crust would have allowed it to form pillars at thousands of locations. Twice a day the shell would have deformed, so the trapped waters of the deep were continually being pumped through the subterranean chamber at high pressure. This work added energy in the form of heat to the waters under the crust. At the same time, each pillar experienced tension, compression, and shear loads twice a day. Friction from these cyclic loads slowly heated the pillars as well. To get an idea of how these forces produced heat, bend a steel wire or a paper clip back and forth several times, then touch it at the bend. Now imagine how much heat would be generated at the extreme pressures in rock 60 miles deep. As tidal pumping continued, the pressure and temperature in the subterranean chamber increased. Eventually, liquid water changed phase into a state known as supercritical water. The hydroplate theory is not the first to recognize the possibility of a supercontinent. We all learned about Edward Bullard's Pangea concept in high school. Few of us were encouraged to look at it critically, however. For example, what happened to half of Mexico and Central America? And what forces rotated North America clockwise, while South America was rotated counterclockwise? We also probably did not catch the fact that Africa's area is actually 35% larger than we were shown in the books. That's right, Africa had to be scaled down by about 35% to make it fit the picture. In fact, Africa and Europe fit poorly with the Americas when positioned in 3D on a globe. especially when you include the continental shelves that extend under the oceans and do not allow removal of materials as needed in order to force a fit. There is another feature on the globe that fits these coastlines much better. One of the key observations Walt Brown has made is that with an actual 3D globe, the coastlines of all four continents fit very well with the mid-oceanic ridge. Discovered in the 1950s, the ridge, which wraps around the Earth like the seam of a baseball, is the longest mountain chain at 46,000 miles length. The fact that this is almost entirely covered by water is not the only trait that sets it apart from today's continental surface mountains. As we'll soon see, the mid-oceanic ridge is a scar in Earth's mantle left over from the flood, which roughly traces the path of the crack that opened up in the granite shell. Surface mountains appear to be the result of compressed materials that have been piled up. This makes sense. Push compressed material together and it piles up. But the mountains of the mid-oceanic ridge are uniquely different than surface mountains. Tensile fractures show that the material has been pulled apart in two perpendicular directions. This is counterintuitive. How do you build a mountain chain by pulling material apart, in two directions no less? Hydroplate theory explains the unique conditions that produced this strange global geologic feature. We will discuss how this happened later, but first let's continue to investigate the nature of supercritical fluids, since it is key to understanding and grasping the magnitude and direction of energy released during the flood. The Genesis flood is not just an unusually long rainstorm as most imagine. As we'll see, rain was a readily observable effect of much more violent causes far below the surface. The waters of the Great Deep were the true source of energy. This energy was stored in and released from the supercritical water in several ways. First, let's discuss supercritical water a bit more. What is the supercritical phase? Boiling water will remain at the same temperature of 212 degrees Fahrenheit at atmospheric pressure. Apply more heat and it will simply boil more rapidly. However, the water temperature will not change as long as the vapor produced is allowed to escape. Place a cap on the container and both the pressure and the temperature of the water will now increase. Since all mass within the container is trapped, density of the vapor increases while density of the liquid decreases. Eventually, the density of the gas and liquid become equal. Microscopic droplets are suspended in the midst of the dense high-energy gas vapor. The potential energy stored in the water at this state is tremendous. The huge surface area of the droplets allows supercritical water to quickly dissipate added heat by evaporating all at once. Rather than increase in temperature, heated supercritical water, if allowed, will simply expand rapidly, converting heat into kinetic energy. Liquid water exposed to heat can only cool through evaporation off of its surface area. However, surface area of normal liquid water is limited and therefore the temperature of the liquid will increase because the surface area is small. Because the liquid surface area of supercritical water is enormous among trillions upon trillions of tiny droplets, supercritical water can evaporate many molecules simultaneously. If allowed, supercritical water will simply expand rather than increase in temperature. If more energy is added, the expansion accelerates. So that is some cursory information on supercritical water. But another form of energy stored in supercritical water was electrical ionization energy. So what is ionization energy? Under normal conditions in an open environment, occasionally molecules of a fluid will collide. When they collide with enough energy, the molecules will break apart into charged ions. This happens rarely with water in an open environment. A closed and pressurized environment forces molecules closer together, increases fluid pressure, and makes collisions more likely. Increasing temperature causes the molecules to vibrate faster. The closer proximity and increased movement causes more collisions. This causes ionization of the water. If pressure suddenly drops, the charged particles will rapidly seek an opposite particle. The sudden and multiple ion collisions back into whole molecules releases much heat into the fluid. Twice a day for centuries, the tidal pull of the moon, and to a lesser extent the sun, would have lifted and done work on the Earth's crust. This would have increased the thermal and ionization energy of the waters of the Great Deep, causing it to eventually become supercritical. Remember what happens when heat is added to supercritical water and allowed to expand. Supercritical fluids are studied today mainly for their great potential for dissolving minerals. The greatly increased energy of fluid molecules impacting against a solid will break up and dissolve the solid much more than would normally occur with less extreme conditions. Centuries before the flood, tidal pumping had heated the subterranean waters to a temperature above 705 degrees Fahrenheit, and the water became supercritical and began to dissolve the more soluble minerals in the chamber's floor and ceiling. For centuries, supercritical water dissolved the more soluble minerals in the granite and mantle, creating porous openings in the rock above and below the subterranean chamber. Once elements like sodium, calcium, carbon, chlorine, oxygen, and magnesium were released by the supercritical water from the solid structure of the rock and into the solution, they were free to combine, forming new molecules like limestone, dolomite, and salt. These minerals eventually precipitated out and heavily blanketed the chamber floors of the great deep. In the granite, this resulted in shifting of the embrittled material as tidal effects stretched and heated the granite pillars. Due to gravitational settling, denser trace materials like iron and nickel naturally collected in the lowest portions of the pillars of the crust. The porous region of the mantle that was dissolved by the supercritical water formed the density boundary today known as the Mohorovicic discontinuity, or the MOHO. In the oceans today, thick plumes of hot, supercritical water known as hydrothermal vents or black smokers are still escaping from the porous MOHO beneath the ocean floors in places. The high heat and pressure of the supercritical water still flowing from these vents shows that the flood event was relatively recent. In the years before the flood, as pressure increased in the waters under the crust, the compression which maintained the seal in the granite was replaced with tension loads as the pressurized water below expanded and began to stretch the crust. While granite has rather good compression strength at 23,000 psi, it is very weak in tension, only around 600 psi. Eventually it failed and a crack developed at the surface and in seconds raced completely through the 60-mile thickness to the pressing waters below. This crack raced across the crust, circling the globe twice in about 2 hours, covering around 46,000 miles. The record in Genesis 7:11 can be taken literally when it states that all the fountains of the great deep burst on the same day. A tension crack in granite will travel at nearly 3 miles per second. In this case, the crack propagated at this speed in 2 directions. The starting point of the crack appears to have occurred near what is now the Arctic Circle, somewhere in the East Siberian Sea. As stated before, the mid-ocean ridge is a scar on the ocean floor that roughly traces a great circle path of the crack that opened up in the granite shell above. As you are looking at this map, remember that hydroplate theory proposes that the continents as we know them today have slid to their current locations and thus have covered some sections of the mid-ocean ridge. This explains why the North American Rocky Mountain chain is bolstered by multiple adjacent chains and so appears much thicker than the narrow chain of South America's Andes. Notice that the mid-ocean ridge bisects itself at right angles in the Indian Ocean. This marks the point where one end of the crack intersected the other, which had already passed by. Since the two ends of the crack traveled at about the same speed, we can measure back equal distances to find the approximate initiation point. Now superimposing the original crust above the map, we can clearly see the mid-ocean ridge bisects itself by running the animation forward in time. The end that raced from the Indian and Pacific Ocean side reached the T first. Therefore, the other end coming around the African side abruptly stopped at that location. Note that this is much easier to see using a spherical globe rather than the distortions that come from a flat map. You can experiment for yourself with Google Earth's path tool by tracing the continuous path starting with the T in the Indian Ocean along the mid-oceanic ridge until you loop back to the T. Google Earth will tell you how long the path is, so simply divide the distance by 2 and then right-click on the path you just made and select the Show Elevation Profile option. A graph will pop up and then simply move the elevation bar to the halfway distance that you just calculated. An arrow will trace the path and show the spot on the globe. See what initiation point you get. Next time you hear the dogma that the mid-ocean ridge is a result of seafloor spreading, notice that usually only the Atlantic or Pacific ridges are given as examples. Now ask yourself how the typical seafloor spreading scenario fits over the mid-ocean ridge in the Indian Ocean. How is the material moving away in 4 directions, and perpendicular to itself? How do the forces produce spreading here, and not also produce spreading up here? Why does the spreading suddenly stop at the crossing ridge and not continue through? If material is moving in these two directions, why are there no signs of compression or trenches in this area? Or does hydroplate theory offer a more reasonable explanation for this feature as we just saw? You may wonder why the crack did not stop moving once the water pressure was first relieved. It is because the subterranean waters were all connected and therefore at basically the same pressure. The speed of sound in granite is much faster than in water, and pressure waves in any material can only travel at the material's speed of sound. So the granite crack always raced far ahead of the water's pressure drop. Imagine you are looking at a cross-section of the granite where the crack passes by. Now we will pictorially see why the crack did not stop moving once the pressure was first relieved. Again, the subterranean waters were all connected and at the same pressure. The speed of sound in water is only about 1/3 the speed of sound in granite. So the leading edge of the crack always raced along the surface far ahead of the water's pressure drop. So you'd see the granite separate long before you felt the drop in the water's pressure. We speak of a crack initiating, but because the continents were so large and had been stretched over thousands of miles, there was a great deal of elastic strain in the plates. This thinned the plates slightly, just like a rubber band will thin as it stretches. And like a stretched rubber band, the granite stored strain energy like a spring waiting to snap. So once the crack sped through the granite, the tension in the plate was relieved, so the plates snapped back like a rubber band, breaking and quickly producing a gap a few miles wide. Then the high-pressure supercritical water jetted violently out of the rupture. Again, Genesis 7:11 records the events of that day. In the 600th year of Noah's life, on the second month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened. This is the first time in the Bible that any event is recorded so precisely down to the day. They obviously witnessed something much more than a heavy rainstorm. Very literal fountains of the deep shot up, accelerating high above the atmosphere at hypersonic speeds. Some scoff at the idea that water could be ejected so high. However, high-speed vapor plumes have been observed presently on the moons of Enceladus and Europa. These examples give a glimpse of the much more powerful forces that Earth would have produced. The blue arrows represent the pressure of the waters of the great deep due to the weight of the granite above. For every action there is a reaction, so for equilibrium or no movement, the force of the blue arrows must equal the force of the red arrows, which represent the reaction force of the mantle pushing back. As we progress, pay attention to the blue and red arrows. The pressure of the water near the crack would drop. Since the pressure in the middle of the granite plate would be very high, while the pressure at the crack would be very low, this would cause the edges of the unsupported granite to bend down, creating a tapered nozzle at the crack. Remember, most of the weight of the granite was carried by the pressurized waters. As the subterranean water was escaping, pillars had to carry a greater load because the subterranean water pressure was dropping and therefore carried less of a load. Eventually, the pillars, which were brittle and porous from centuries of contact with supercritical water, failed from the added weight and began to crush and break up into fragments, causing enormous earthquakes within the plate. Every time a hydroplate oscillated down, it partially closed the nozzle-shaped edge of the plate. An entire ocean of escaping water was then forced to slow down, producing what is known as a water hammer. Water hammers can cause pressure spikes many times the initial pressure in a flowing fluid. Every time this happened, velocities at the crack would have spiked as well. Whenever a liquid or gas flows over a flexible surface, the flow can induce flutter in the surface. This is easily seen in a flag that is flapping in a strong wind. Hydroplate theory poses that during the beginning stages of the flood, as supercritical water rocketed out from under the plates, the flow of fluid under the plates, in combination with seismic waves from the buckling and crushing of these pillars, induced flutter oscillations in the granite plates which lasted for several weeks. Return oscillations lifted the fractured pillars from their bases, and then slammed them back down into the mantle, producing more vibration and fragments which were swept into the flow. As the edges of the plates oscillated down, flow was restricted while internal pressures spiked. As the plate edge oscillated back open, the tremendous pressure was released, so the fountains pulsed in tune with the plate flutter. It is hard to imagine granite 60 miles thick bending, but consider that the area of the plates was thousands of square miles across, so on a continental scale the plate thickness was tiny. Remember that many of the views you'll see here are out of scale so that we can see the concepts. For example, a more scaled view across the North American continent before it was compressed and thickened would look like this if the granite was 60 miles thick. When you consider that a plate was mostly suspended by a fluid foundation, it is not difficult to imagine bending and flutter in the rock crust. At the point of the crack, pressure dropped from 372,000 psi, or higher due to water hammers, to near atmospheric conditions. Similar to the phase change of a propellant like gunpowder, water changes phase and expands to a gas, increasing volume by 1,600 times. The phase change of supercritical water to gas was similar, but much more energy was involved. Because of this, the volume of expansion was much greater. Remember, the supercritical water contained tremendous stored energy, so while the pressure drop caused some expansion, it also began a chain reaction which released all its stored energy. The sudden pressure drop caused ion collisions, was added heat to the fluid, and because supercritical water's microscopic droplets had almost infinite surface area to evaporate, the added heat almost instantly converted to kinetic energy as the water expanded from the base of the crack. This chain reaction continued to occur all along the flow, which accelerated the fluid from the base of the crack to far above the atmosphere. With no atmosphere to produce drag, tremendous velocities were possible. Finally, in the initial stages of the flood, the waters of the Great Deep were subject to heat from nuclear reactions that appear to have occurred in the granite as it flexed and fluttered above the flow. In objection to Walt's estimates of temperatures of the supercritical water under the crust and the energy estimates involved, some apply simplistic heat transfer equations to the volume and mass of the atmosphere, and then declare catastrophic boiling or vaporization of all life. Others also argue that the hypersonic speeds of the fountains would have pulled the atmosphere up along with it and stripped it from Earth's surface. So is there a heat problem with this theory? If all this energy was released during the flood, would Noah roast? Well, I'd say not likely. Just because high temperatures and huge amounts of energy are involved does not mean everything nearby would be dead. Sometimes a picture gets this point across better than a technical discussion. That flame is probably about 1800 to 2000 degrees Fahrenheit. My hands are less than an inch away and could easily have stayed at that position till the bottle ran out of propane. So first consider that this is a scenario that involves directed energy. Yes, there was tremendous energy involved, but where was it headed? I think some of the confusion arises by immediately simplifying the problem and not accounting for everything happening throughout the entire scenario presented by hydroplate theory. Consider that when a fluid expands, it cools greatly. So by the time the initially high energy water directed far above the atmosphere fell back as heavy rain, any remaining heat would radiate into space, which is a huge, almost infinite heat sink. Remember the picture of my hands just an inch or so beside the torch. Air is actually an insulator, a very poor conductor of heat, especially when it is stagnant. Nearly all forms of insulation, from fur to your coat to your house walls, rely on still air to be effective at preventing conduction of heat. The great speeds of the fountain's flow mean that there will be little time for heat transfer with the atmosphere as it raced past. Like my hands, Noah was located beside and away from the fountains, and the air in between would have protected from extreme temperatures. Consider, too, that the atmosphere is like a wide, thick blanket for Earth, and it has tremendous inertia that would have to be overcome for it to be stripped away from Earth's gravitational pull. A focused, high-speed flow is just about the worst method I can think of for imparting kinetic energy to a gas. If you question this, try an experiment. On a still, non-windy day, light a leftover 4th of July smoke bomb, then use a hose with its nozzle set to its most pinpoint setting to try to move the smoke around or out of your yard. After you get frustrated, try a slow-moving fan and then consider just how effectively a pinpoint, high-speed flow moves a gas. It is a terrible method for moving a gas. Finally, consider that at the top of Earth's atmosphere, temperatures plummet to negative 150 degrees Fahrenheit and lower. So any air beside the fountains that was heated and pulled up with the flow would have a tendency to lose speed, fall away, and radiate any gained heat long before it floated back down. If interested in how this nuclear heating occurred, follow the link shown here to a presentation on the origin of Earth's radioactivity. There you'll find not only the explanation for nuclear heating, but also discover the surprising evidence of plate flutter, how chondrules formed in meteorites, how heavy elements were produced during the flood, and how accelerated radioactive decay occurred, which produced the parent-daughter ratios which so many mistakenly think is proof for billions of years of time. For now, we will skip this subject as it would greatly sidetrack our review of hydroplate theory. Just realize that this nuclear heat produced within the plates greatly pressurized the supercritical water that had eaten into and was now partially constrained within the porous regions of the plates. Because the upper half of the plates were still solid undissolved granite, this pressurized water could only expand laterally and down through the porous channels. The expansion of supercritical water within the openings quickly fractured the lower regions of the plates. These dislodged porous fragments quickly fell into the pulverizing flow and were accelerated up into space. This process quickly eroded and thinned much of the originally thick plates. This would explain why the estimated 60-mile thick plates were eroded to today's average of about 30 miles thick. The flow under the plates produced extreme velocities high enough to launch materials beyond Earth's gravitational pull. These objects are observed in our solar system today as interstellar dust, comets, asteroids, meteors, and Trans-Neptunian objects. Let's discuss some...
This is where Dr. DeLuz told us to turn it off. So from here on was not an ICR.
Smaller rocks
loosely held together by water ice. Both contain salt and silicates, which make up about 95% of Earth's crust. They also contain crystalline silicates, which require uniform temperatures of above 1300 degrees Fahrenheit and slow cooling under pressure to grow. How could this happen in space if space is the origin of these objects? Space is an environment of no pressure and near absolute zero conditions. Limestone and clays are found which require a body of liquid water to form. In 2011, the mineral cubonite was reported in Comet Wild 2. Cubonite only forms in scalding hot water between 122 and 392 degrees Fahrenheit, but comets do not reach these temperatures even at their cores. Comets, asteroids, and meteors contain olivine, which is a common mineral of Earth's crust and mantle. Olivine is also concentrated with iron-nickel in some meteors. Iron-nickel alloys found in meteors contain the unique Widmanstätten pattern, which again means the material formed under uniform temperatures of at least 1300 degrees Fahrenheit. The conditions in the Great Deep easily explain these surprising findings. Finally, and most perplexing, organic compounds, complex molecules, and materials like amino acid and even bacteria are found in these objects. Studies of interstellar dust scattered throughout the inner solar system near Earth's orbital plane find this, quote, dust actually matches the spectral properties of complex structures like frozen bacteria and cellulose. This has led some scientists involved to wonder if these materials somehow seeded and began life on Earth. Considering that their origin hasn't been explained in the ideal environment of Earth, it is baffling to think how these could ever form in the unfriendly conditions of space. For example, what protected these delicate structures for millions of years while fully exposed to harsh solar rays? Traditional explanations for these complex organic molecules are severely lacking. Of course, without question, the Earth's surface has the highest known concentrations of these familiar products of life. Where else does something like cellulose form and thrive? Often these bodies are explained as leftover building blocks of our Earth. So while there is much speculation over the origin of these objects and their content of trace organics, the evidence strongly suggests that we are standing on the source. Although rather large, asteroids like comets have low density and are weakly held together. Vesta is one of the largest and is almost big enough for its gravity to make it spherical. Ceres is the largest asteroid and makes up 1/3 of the mass of all asteroids combined. It has just enough mass to pull itself into a roughly spherical shape. The mass of all known asteroids combined make up only a small percentage of Earth's mass. So asteroids are probably not the fragments of a planet that completely exploded, as some people initially thought. Since asteroids are actually made up of many smaller rocks, dust, and water ice, it is not so hard to imagine them being ejected from Earth via mechanisms we just covered. As these particles traveled farther from Earth, their gravitational sphere of influence increased, so larger rocks gravitationally attracted more and more smaller rocks into their vicinity, which caused their gravitational spheres of influence to grow even more. Eventually, these mergings became comets and asteroids. Those that did not merge to become comets and asteroids are today's meteoroids. Some asteroids became so large that they maintained their gaseous atmospheres for much longer, which allowed them to sail on the solar wind past Neptune's orbit, becoming Trans-Neptunian Objects or TNOs. TNOs share many characteristics with asteroids. Both measure exceptionally low densities of around 2 grams per cubic centimeter. Both are often reddish in color due to the surface rocks containing iron oxide, oxides which likely formed due to the presence of water launched with the rocks in the fountains of the deep. When the mass of all TNOs is considered, then the percentage of the material ejected from the flood jumps to around 3% of Earth's mass. This line of evidence is one of the main reasons for changing hydroplate theory's estimated initial crust thickness to 60 miles. I say special conditions are required to form these objects because the gravity of small objects is tiny. Asteroids and comets would never accrete if the trajectories of objects and the angles of impact were random. Even landing a small, carefully guided space probe on a large asteroid or comet is incredibly challenging due to how low the gravity environment is. If traveling at even slightly differing speeds, impacts in space result in further fragmentation and breakup of particles, which will never return to each other. Just so conditions are required for accretion. All of these special conditions are accounted for and explained by the hydroplate theory. Items must be traveling at the same relative speeds and along the same trajectory. The presence of gases during this process greatly aids in aerobraking the inbound components, providing the best possible conditions for successful accretion. Many asteroids surprisingly have moons like Ida and its moon Dactyl. Capturing a moon is incredibly difficult for the same reasons we just discussed. However, moons would be expected if asteroids originated from a stream of particles with shared velocities and direction. Many TNOs have moons as well, as hydroplate theory would expect. Some TNOs even orbit each other at great distances. Another scenario which requires the unique conditions that only hydroplate theory seems to be able to provide. Some large asteroids have gently connected with their moon, like Itokawa. As stated, it is difficult to do this even with small, precisely controlled spacecraft. When the large size of these fragile bodies is considered, it is hard to imagine how this occurred randomly in space with no gaseous atmosphere to provide aerobraking. Notice that this picture of the surface matches what hydroplate theory predicts. Asteroids are not angular shards of a broken larger planetoid. They are low-density flying rock piles loosely held together by water ice. The rocks are well rounded. In this picture, some rounded boulders are over 150 feet in diameter. High-velocity flow produced many rounded objects discovered on Itokawa. Hydroplate theory readily explains these findings. Meanwhile, researchers like Donald Yeomans from NASA Jet Propulsion Laboratory realize the problem and currently seem stumped by what is observed due to their evolutionary viewpoint. Recent detailed explanations show comets have similar makeup as asteroids. In fact, some asteroids are categorized as both an asteroid and a comet since they sometimes vent gases and dust producing familiar tails. Comet nuclei like the one shown are low-density, dirty snowballs composed primarily of water ice, dust, organics, and curiously again, rounded boulders. The surface of Comet 67P has layer upon layer of large rounded boulders at least 10 feet in diameter. This would not be expected if these fragments were due to collisions in space. They should be jagged and angular. Of course, rounded boulders is exactly what is expected if these fragments were once exposed to and tumbled in an extremely high-velocity flow as they were ejected from the fountains of the deep. This is the same mechanism by which river rocks are rounded, albeit these large, quote, dino eggs were rounded much faster. Here's a close-up of a crater where hundreds of these rounded 10-foot boulders are exposed. Here again, rounded boulders are observed on the peanut-shaped comet Hartley 2. Like the subject of the origin of Earth's radioactivity, the hydroplate theory's full explanation of the origin of comets, asteroids, meteors, and TNOs would take us on a long bunny trail that would distract from this overview, so we will have to leave this subject and move on.
Okay, we're going to stop that because that's the rest of part 2, and now we're going to go to what he said to click on to get.
This discussion goes into some further detail on hydroplate theory's explanation for the origin of asteroids, comets, and Trans-Neptunian Objects, or TNOs. Rather than repeat information that has been covered in Part 2 of the overview series, I'll simply delve into this side topic. So you may wish to review the end of Part 2 of the overview presentation to get the introductory info on why asteroids, comets, and TNOs are very unlikely to be the building blocks of the solar system, and see the many telling evidences that point to the Earth itself as the most likely origin for these objects. This presentation provides more information on the origin of meteorites and a more detailed explanation for why hydroplate theory says that rocks and water in the fountains of the Great Deep later merged to become comets, asteroids, and TNOs, and how those bodies, after they formed, ended up in their present orbits. Finally, we'll review how the moon's scarred surface is actually evidence of this powerful launching of material from Earth. Notice that the hydroplate theory is not saying that asteroids, comets, and TNOs came fully formed from the Earth. Rather, these bodies formed in the weeks, months, and years after the flood began from the rocks, water, gases, and other compounds launched into the inner solar system by the fountains of the Great Deep. Of course, some ejected bodies did not combine to form larger bodies. These smaller, rocky, sometimes metallic bodies are called meteoroids. Those that have returned to Earth's surface are meteorites. Studies reveal that meteorites contain a variety of surprising materials which have experienced a unique and turbulent past. The following items have been found in meteorites: chondrules, salt crystals, water, limestone, which only forms in liquid water, DNA components, possible cellulose, sugars, living and fossil bacteria, terrestrial-like brines, excess left-handed amino acids and heavy hydrogen, and Earth-like minerals and Earth-like isotopes. All these implicate Earth as their source and the fountains of the Great Deep as the powerful launching mechanism. Meteorites can be divided into three classes. 95% are stones, rich in silicon and the mineral olivine, both common on Earth. 4% are irons, which are an iron-nickel mixture that was initially molten and experienced uniform heat of at least 1300 degrees Fahrenheit, as evidenced by their unique Widmanstatten pattern. Finally, 1% are an intermediate class of stony irons called pallasites. Pallasites formed from a molten iron-nickel mixture which seems to have been injected into or mixed with fragments primarily of olivine. The mixture of metal encasing olivine and other rocky minerals is surprising because the iron-nickel alloy is twice as dense as the minerals. The metals were molten when they solidified around the stones, but the less dense stones should have quickly floated to the top. Just as you would expect ping-pong balls to float on the surface of a bucket of water. But what if you found the balls frozen within the water? Pallasites are just as surprising. It has been proposed that pallasites are fragments of an imagined large asteroid that had a molten metal core which was pressed into the rocky crystals at the core mantle boundary. Later, this asteroid is imagined to have catastrophically broken up, releasing the pallasite mixture of iron and rock fragments. If this were the case, cooling rates of all these fragments would be uniform. However, research on 8 different pallasites concluded that the molten iron-nickel mixtures cooled at such diverse rates that they could not have originated at a core mantle boundary, even in an asteroid. There are other problems with this idea. Asteroids are not strong, dense rocks that would become molten if struck in the necessary high-speed impact that is imagined to have created the molten condition in the first place. Rather, asteroids are fragile, low-density floating piles of rock loosely held together by water ice. An asteroid will not develop a molten core if a meteoroid slams into it. Remember, asteroids are flying rock piles, so a large impact will scatter the rocks that make up the asteroid. Besides, asteroids are extremely cold, and because they are so much smaller than a planet, they lose their heat much faster. So in light of these physical challenges, the scenario that would get an asteroid to melt such that it would produce much less support a molten core seems very unlikely. Finally, pallasites contain remnant magnetism, yet there is no hard evidence that any asteroid ever had a magnetic field, although many hold to that idea. Of course, Earth has a powerful magnetic field, and as my other video on the origin of Earth's radioactivity shows, powerful electromagnetic discharges were released within the crust at the time of the flood. Hydroplate theory poses a much different scenario explaining the formation of pallasites. Tidal pumping from the moon and the sun stretched and compressed the pre-flood Earth's pillars twice a day. For centuries before the flood, the heating from this cyclic compression and internal friction within the pillars heated the materials in the subterranean chamber. After a decade or so, the subterranean water became supercritical and ate into the pillars, making them porous and brittle. Due to gravity, over time, dense metals with lower melting points than rocky minerals slowly migrated through the now porous structure toward the pillar's base. Once the crust was ruptured, the pressure in the supercritical water under the crust began to drop, Remember, most of the weight of the plates was supported by the pressurized waters. So as the water pressure dropped, the pillars had to support more of the crust's weight. The pillar material was crushed under the added weight. The friction from small slippages in the failing pillars melted materials at points all along the fractures. The melted material then acted as a lubricant, which encouraged further slipping and melting of nearby material. Rather than slow migration through tiny pores, the many fractures became conduits which more quickly sorted materials due to gravity. Dense liquid iron and nickel moved down toward the pillar bases, while low-density materials and minerals that melted like quartz and trapped supercritical water were displaced and migrated upward along the same faults. Fractures in the crushed rocky minerals at the pillars' bases became engorged with molten iron and nickel. As the plates above began to slowly flutter due to the movement of the escaping supercritical water, these fractures received powerful high-pressure injections of molten material from above. The fractured solid minerals, which were lower in density and had higher melting temperature, were further pulverized as liquid metal began to pool at the bases under extreme pressures. As the amplitude of the fluttering crust above increased, the pillars were lifted from their bases in tune with the crust's oscillation. Pooled metals and stony minerals encapsulated in liquid metal were quickly swept into the flow toward the ejecting fountains. As the pillars oscillated down, they were slammed back into the mantle bases. Pressure spiked more. Crushing, melting, and injection of iron and nickel into the bases occurred. Quartz and other minerals with piezoelectric properties discharged as the pressure waves rippled through the buckling pillars. At points, powerful electrical discharges pinched nuclei together in small fusion events, which melted surrounding materials, forming chondrules within some of the rocky matrices. These same discharges subjected the surrounding materials to intense magnetic fields as they were forming. This and the Earth's magnetic field explain why pallasites are found to have remnant magnetism today. For more detail on the physical mechanism that resulted in these fusion events and chondrule formation, refer to my other video titled The Origin of Earth's Radioactivity. Hot fragments of crushed pillars and mantle bases were chaotically tumbled and accelerated by the rushing supercritical water toward the open ruptures in the crust. Reaching the base of the ruptures in the thick crust, the fragments were further pulverized and tumbled in the flow, which greatly cooled as it accelerated out and experienced free expansion into the vacuum of space. In a matter of seconds, material experienced rapid thermal shock from the extreme heat under the plates to the extreme cold in the expanding flow into the equally cold vacuum of space. The metals quickly solidified around the slurry of stony minerals, trapping and freezing around them, forming a unique matrix of dense metal and mineral crystals. The chaotic tumbling and rapid ejection into the weightless vacuum of space explains why the low-density minerals were unable to separate from the dense metal matrix. These events also explain how molten chondrules formed within some stony pillar fragments, due to powerful electrical discharges. Intense uniform heating of the iron-nickel alloys under the pillars explains iron meteorites' unique Widmanstätten crystalline pattern. The many variables at play as the plates and the fountains pulsed, such as the distance from a given pillar to the nearest rupture point or the intensity of a fountain pulse, made for much variability in the rate that ejected fragments cooled. Therefore, hydroplate theory's mechanism of formation simply explains why different pallasites are found to have cooled at very diverse rates. They did not come from an imagined asteroid's unlikely core boundary. They came from Earth. This, of course, explains why meteorites share so many Earth-like materials and properties. We'll now focus attention on comets, asteroids, and TNOs. Remember that comets are loose collections of ice, dust, and small rocky particles. Asteroids are small, minor planets that revolve around the Sun, with orbits lying chiefly between Mars and Jupiter. And a Trans-Neptunian Object, or TNO, is any minor planet in the solar system that orbits the Sun at a greater average distance than Neptune. To understand the origin of these objects, we first should cover how objects fall in a gravitational field. In other words, how objects orbit each other. If you were on a tall mountain and fired a cannon, you'd expect the ball to travel some distance and then hit the ground as gravity pulls the ball down. If you added more and more cannon powder, the ball would travel further and further, yet gravity would still pull the ball down. If you could trace the path of the ball from the side as we are viewing it here, you'll notice that the arc shape of the path of each successively faster shot more and more closely matches the circular shape of Earth. If you could get the cannon to fire the ball at around 17,000 miles per hour, then the ball's falling arc would match the curvature of the Earth and the ball would simply continue to fall completely around the Earth and never come down. This is circular orbit. If you could fire an object even faster than this, the object would enter an elliptical or egg-shaped orbit and travel far from Earth. Objects fired far from Earth will eventually become captured by the Sun's gravity, and they would then orbit the Sun rather than the Earth. The object would travel progressively slower as it traveled further and further along the elliptical path, until it reached the furthest point in its orbit, called its aphelion. Then, as gravity pulled it back, the object's speed would again increase as it fell back toward the Sun, where it would be the nearest to the Sun and traveling the fastest. This is called the object's perihelion. If you could fire the object even faster, the elliptical orbit shape would become more and more eccentric, until another threshold is reached, which is called a parabolic orbit. Parabolic orbit is the dividing line between closed elliptical orbits and open or hyperbolic orbit. If the object were traveling any faster, it will enter open or hyperbolic orbit, meaning that it is not really in orbit around the Sun anymore and will never return. In other words, the object travels at a high enough initial velocity that even though it slowed as it moved away from the Sun, it moved so far away, so rapidly, that the Sun's gravity out at what would be aphelion for the object is too weak to pull it back. So the object escapes the Sun's sphere of influence out to infinity. Some comets have been observed to be on just barely outbound open orbits. However, no comet has ever been seen falling toward the Sun on an open orbit. This is an important point when we consider what we've been taught to believe about comet origins. What do we observe today? There are just over 1,100 comets whose orbital parameters are precisely known, and around 2,300 more comets have been observed, but not long enough to determine orbital parameters. Some of these observations may be of the same comet at different times. The streams of dust and gas released by a comet form a huge, extremely thin atmosphere around the comet called a coma. A common property of all comets that have been inspected more closely is that they are made up of a loose collection of ice, dust, and surprisingly well-rounded rocks. The density of each comet's nucleus is extremely low, about that of foam, talcum powder, or a meringue on a topping of a pie. So despite their dust and gaseous tails being sometimes larger than 1,000 Earths, comets have very little mass. Most cosmologists agree that the source of most comets must be a cloud of material termed the Oort Cloud, composed of trillions of comets in a spherical shell surrounding the solar system. A cloud so far away that no one has ever seen it or detected it in any way. Carl Sagan has admitted, and I quote, "Many scientific papers are written each year about the Oort Cloud, its properties, its origins, its evolution. Yet there is not a shred of direct observational evidence for its existence." So in spite of much speculation, not one new inbound open-orbit comet from the imagined Oort Cloud has ever been observed. However, many comet deaths or disintegrations have been observed. One of the main contributors to comet deaths are the planets themselves, mainly Jupiter, the most massive planet. Comets with aphelions that lie near Jupiter's orbit, like comets A and B shown in the animation, will be greatly affected by Jupiter's gravity. These comets are part of a group called Jupiter's family. 60% of short-period comets are in Jupiter's family. Unfortunately, short-period comets have been arbitrarily defined as comets with periods less than 200 years. A more physically meaningful definition used here will be comets with periods less than 100 years, because there is a huge recognized excess of such comets. So any acceptable theory of comet origins should explain the excess comets with periods of less than 100 years. Surprisingly, simulations show that comets in Jupiter's family will last only about 12,000 years before they collide with a planet or Jupiter's gravity rips them apart, or flings them out of the solar system. In 1992, we all saw Jupiter rip Comet Shoemaker-Levy 9 into 21 pieces that one orbit later collided with Jupiter. A question immediately arises. Where did the current crop of short-lived comets come from if these have supposedly been around for billions of years? Extrapolating these comets' short 12,000-year half-life back in time to billions of years ago will indicate that initially there must have been an unrealistically large number of comets in Jupiter's family. How is this explained? Or from this data, should we consider if this doomed small population of comets was actually produced recently about 5,000 years ago as a result of the flood? This would readily explain why many comets have managed to survive today in such a deadly environment. We've been taught the Oort Cloud theory, which attempts to explain the origin of comets. The distance from the Sun to the Earth is defined as 1 astronomical unit, or 1 AU. The Oort Cloud has never been seen or detected in any way, but it is imagined as a shell of comet materials that are dispersed about 50,000 AU from the Sun. As I've already mentioned, it's curious how several outbound comets have gained enough energy from interactions with the planets to be flung out of the solar system. However, astronomers have never confirmed a single inbound comet in open orbit from the imagined Oort Cloud. This is a troubling lack of evidence for the Oort Cloud theory and leaves open the problem of explaining how comets have supposedly existed for billions of years while planets like Jupiter have been rapidly vacuuming them up. Hydroplate theory proposes that the material that later merged to become comets, asteroids, and TNOs was launched during the flood. In part 1 of the overview series, I've already discussed how their physical and chemical components are very similar to the materials and conditions found on Earth. In fact, some of those materials, like amino acids and complex organic compounds, are uniquely concentrated and abounding on Earth. Hydroplate theory looks at 3 orbital properties of comets that can be tied to the components of relative motion that all comets received from the Earth's orbit. Observed comets are distinctively grouped as follows. For each group of comets, we will review their properties and see how they relate to how rapidly they were ejected from the Earth. A comet's orbital period is the time it takes a comet to complete one orbit around the Sun. Obviously, Earth's orbital period is 1 year. Next is the comet orbit's angle of inclination, which is the angle of the comet's orbit measured from the Earth's orbital plane. Finally, the orbit direction is defined as either in the prograde direction if the comet is orbiting in the same direction as Earth orbits the Sun, or retrograde if the comet is orbiting in the opposite direction as Earth. Today, at least 1,118 comets with calculated orbits have been identified. Their orbits can be grouped into 3 categories of short, medium, and long orbit periods or cycles. About 729 comets have periods of 100 years or less, and only 102 comets with medium periods of 100 to 700 years, while 287 comets have periods that exceed 700 years. We will next look at how hydroplate theory explains the existence of short, medium, and long period comets. First, we will discuss the concept of relative motion. Imagine you had marked 3 lines on the ground next to a rail track. Imagine a train comes down the track at 100 miles an hour, and assume that the moment the train passes your lines on the ground, 3 balls are launched backward from the train cars at the same angle. The only difference is the balls are launched at different speeds. The ball tossed at only 50 miles an hour in the backward direction would actually hit the ground well forward of the point it was thrown from because the ball was traveling on the train at 100 miles an hour. So because it is so slow, most of the green ball's trajectory matches the direction and speed of the train, even though it was thrown at a rearward angle. We could say that the motion of the green ball has a noticeable signature imprinted on it by the train's trajectory. The 150-mile-an-hour ball pitched at the same angle would still fall forward relative to the ground. However, you can see that the yellow ball's path is less affected by the train's speed and direction than the green ball. The train's relative motion signature on the yellow ball is less pronounced than that of the green ball. Finally, if you fired the red ball at 500 miles an hour at the same backward angle from the train, the ball would finally land at a point behind the line on the ground because the train's relative motion does not affect the red ball's overall trajectory nearly as much as it did with the yellow and green balls. The train's trajectory signature is very faint for the red ball. Now imagine you threw many balls at 50 miles an hour, each at a random different angle. What would you expect? Well, we'd find that for all the green balls, the train's contribution to the velocity is so dominant that every one would land in front of the line on the ground no matter which angle you threw them. Now repeat this thought experiment for the faster yellow balls. The train's velocity plays a lesser role, so only a small percentage of the balls pitched directly rearward would actually land behind the line on the ground. And finally, the train's speed and direction play only a minor role in affecting the balls fired at 500 miles an hour. So if we repeated the experiment at the final time for them, we would see that a more equal percentage of balls land on either side of the line on the ground. If you increase the speed even more, the percentage aft versus forward of the line would near 50-50. Now let's use this discussion to see how a similar signature of Earth's relative motion can be seen in some comet trajectories and not so much in others. Short-period comets are like the green balls. They have short orbit cycles, so they were not ejected at as high a velocity from their source. So the Earth's orbit signature is readily seen in several ways. The orbit angles are very slight and do not stray much above or below Earth's orbital plane. Very interestingly, 97% of all short-period comets are prograde. They orbit in the same direction as Earth. Medium-period comets are like the yellow balls. They were ejected at higher velocity from their source, so the Earth's orbital signature can be seen, but is less pronounced. The speeds are high enough that orbital angles of inclination are dispersed in all directions. But only 58% of medium-period comets still maintain the same prograde orbital direction that Earth has. 42% were launched with enough energy and at just the right angle to have taken a retrograde orbit. Long-period comets are like the fast red balls. They were ejected at the highest velocities from their source, so the Earth's orbital signature is not readily seen in this family of comets. Again, the orbital angles are dispersed in all directions. In addition, the orbit directions for long-period comets are pretty evenly split, just about 50-50 between prograde and retrograde, as we'd expect with the spinning Earth randomly firing these objects at extreme velocity. Next, we will focus on asteroids. According to hydroplate theory, the ejected clouds or swarms of materials that later formed into asteroids would have most likely entered an elliptical orbit with the Sun. Why, then, are most asteroids not in comet-like orbits? Why are most asteroids shown as white dots in this picture in nearly circular orbits concentrated in the donut-shaped asteroid belt between the orbits of Mars and Jupiter? Shouldn't some asteroids have high angles of inclination? A puzzling question then arises when we look at the asteroid belt today. Most asteroids shown as white dots have a near circular orbit between Mars and Jupiter. If hydroplate theory is correct, how did asteroid orbits become circular and expand out beyond Mars and Jupiter? Even more puzzling, how did large asteroids become TNOs far beyond Neptune's orbit? Also, per the hydroplate theory, this ejected material would have been launched from Earth in many random directions and highly inclined angles. This would tend to produce more of a spherical asteroid shell. Yet the asteroid belt has a donut shape and is centered near Earth's orbital plane. So how did ejected materials with highly inclined orbit angles change to become asteroids concentrated near the orbital plane? There were several special conditions immediately after the flood that produced several persistent but powerful forces due to energy from the Sun. The first is the radiometer effect.
This is a radiometer that you can get from Amazon for about $30. And the way it's been manufactured is that there's a spinning wheel in here that spins around. There's a dark side and a light side, a tinfoil reflective side on these little vanes in here. And the inside of this glass bulb has been evacuated, taking most of the molecules of air out of this demonstration. And so there's no batteries, no electrical power, and there's just this spinning wheel that's sitting on top of a needle, very little resistance to turning if there's something that makes it turn. And what Brian Nichols explains in his video that you're about to see is this radiometer effect. What happens with the molecules inside of here, there's not many of them, so there's not much wind resistance with these vanes that are in here. There's not much wind resistance inside. Most of the molecules have been pulled out and evacuated. But the ones that are still in there are, billions of times are hitting these different surfaces of these vanes. Well, the vane that's dark is going to absorb the light. The heat from this lamp, the photons of this flashlight are going to, is going to hit the dark side and give energy, heat energy from the photons, which causes the molecules that are there are going to hit the hot side and come off with the energy of the heat at a faster rate than the tinfoil side. And so that means that as long as asteroids, comets have an atmosphere of molecules, gaseous molecules, when the sun heats up the dark side of the spinning out asteroid, the molecules are going to be pushing off of that asteroid in a way that is going to give it a thrust, just like this flashlight is giving a thrust to those veins inside of there by heating up the black side and the molecules coming off of it with greater velocity than the molecules that are bouncing off of the tinfoil colored side. And that will continue to work until the asteroid loses the gas or it gets too far away for the sun to heat up the asteroid. And that's why in the asteroid belt, the ones that are furthest out, closer to Jupiter, are dark asteroids because they were able to maintain the radiometer effect because of the light of the sun heating them up, giving them more thrust for a longer period of time. So as soon as I pull this light off of here, it stops turning. Now, they knew that this happened, but they couldn't explain it. It actually took Einstein to explain what I just gave to you, because it is very complicated and in a sense of the physics associated with this. But this is energy. Light energy can create a thrust of the comet and asteroid debris as it's spinning out, or going out into a further orbit to get into the asteroid belt between Mars and Jupiter for the asteroids.
We'll cover the next two lesser-known forces in more detail. Some spacecraft today are being designed with solar sails to take advantage of the sun's steady solar wind to reach destinations far faster than conventional rocket technology. Each particle in an ejected cloud of material that was forming in an asteroid also felt this steady flow from the sun. In space, rotating bodies and atmospheres in the presence of sunlight experience cyclic heating. Depending on the speed of rotation and other factors, this system has been shown to act like a Carnot engine, which produces a weak but steady thrust force that pushes or propels the rotating body away from the light source. Together, these forces acted continuously for centuries after the flood to accelerate these bodies and change their orbital trajectories. Finally, we'll also see how gases expelled from the fountains affected the orbits of clusters of particles as they passed through these dense gases that remained near Earth's orbital plane. Since all ejected material originated at Earth's orbit radius of 1 AU from the Sun, particles were attracted more to the gravitational center of the group of particles than to the Sun's. At first, these clouds of expelled dust, rocks, and gases were exceedingly large. The largest rocks launched into orbit about the Sun became the seeds that gravitationally attracted smaller nearby particles traveling with about the same speed and direction. That swirling collection of rocks, gas, and water ice caught in the seed rock's sphere of influence will be called a swarm, and was much like a swarm of bees with one difference. The gas in the swarm applied an aerobraking drag on the swarm's rocks so that the entire swarm slowly contracted, a process called aerobraking. This contraction of mass about the seed rock increased its mass and grew the sphere of influence, so that even more debris was attracted and joined the swarm. Eventually, swarms collapsed and became comets, asteroids, and TNOs, depending on their size, orbit, and water ice content. No sharp line separates comets and asteroids. In fact, some are considered both a comet and an asteroid. The larger asteroids spiraled out to become TNOs. A swarm's mass initially occupied such a large volume that its density was tiny. As photons of light radiated from the sun, they struck these large clouds, transferring their momentum to the particles and gases. Photons from the sun applied an outward force on the swarm. By outward, I mean away from the sun. Much like a steady wind would accelerate a low-density cotton ball. But there were two important differences. First, the swarm moved in the vacuum of space, so it did not experience the drag a cotton ball would receive in our atmosphere. Also, the sun's energy heated the daylight side of the swarm, so the swarm's higher atmospheric pressure on the daylight side pushed the swarm outward. These acted collectively like a sail on a ship, so the solar wind gently but continuously accelerated the swarms of collecting particles far away from the sun. This solar sail effect had the most impact on the swarm's velocity right after the flood, when the swarm's sail diameter was the greatest. Man-made solar sails are only a few feet in diameter. By contrast, swarms would have initially been thousands of miles in diameter, so they received tremendous momentum from the sun's rays and over time traveled great distances. The energy from the sun's rays can produce another effect for these small, low-density objects as they rotate in their orbit about the sun. I specify small objects here as opposed to large, dense bodies like the Earth, which would see similar forces, but are so dense and massive that the effect on Earth's orbit is essentially zero. A fully intact small body is shown here for ease of illustration, but realize this effect also works similarly on loose swarms of rocks and gases as they rotated about a common center of gravity and slowly contracted to form asteroids. For any body in the presence of the sun, there is a day side and a night side, which if it is spinning, we can think of, as we do on Earth, as being split into times of day, 6 a.m. being dawn, noon being midday, etc. Of course, the length of time of this body's day would depend on the speed of its rotation, so the day's, quote, hours discussed here would not necessarily be 60-minute periods. The swarm's atmosphere on the day side is heated by the sun, while on the night side the atmosphere loses heat and cools. The highest temperatures occur at what we might call 2 p.m. in the afternoon, while the coldest temperatures would occur just before sunrise on the swarm. A resulting force acts on the rotating body along this line. This force acts like a weak but steady and continuous thrust on the body. The difference between the heat absorbed and the heat rejected became thermodynamic work, that is, force acting through a distance. Force acting on mass produces acceleration in the direction the force is applied. This thrust force consists of two components in this case. The component that aligns with the body's orbital trajectory will increase the body's angular momentum, while the other component acts to increase the orbital radius of the body. Realize that while these vector arrows continuously change direction depending on the position relative to the sun, orbit direction, and the body's rotational speed and direction relative to its trajectory, the resultant effect is always a thrust force away from the sun. This change in trajectory is a bit hard to imagine, so it helps to see this animated in time. As the white thrust force arrow acts on the rotating body due to the cyclic heating effect from the sun's rays, the path of the object is diverted from its initial trajectory and slowly drifts away from the sun. We sometimes forget that there is no drag in the vacuum of space, so even though these forces were tiny, their continuous effect over centuries resulted in tremendous velocities and greatly altered orbits. Not all materials ejected from Earth during the flood were launched with enough velocity to become asteroid or comet swarms with large elliptical orbits. This low-velocity debris, mainly gases, maintained a circular orbit and remained near Earth's orbital plane since it generally matched Earth's orbital parameters. For a time after the flood, these gases were encountered every time a newly forming asteroid swarms passed through the inner solar system. Swarms on orbits with steep angles of inclination felt drag from these gases, so this too gradually made elliptical orbits more circular and acted to reduce their angle of inclination on every orbit cycle. As the swarm entered the inner solar system and encountered the gases, the drag acted on the swarm to slightly alter its trajectory to a flatter inclination angle. Remember, this would have happened for many centuries after the flood, so obviously the change shown here is exaggerated to see the concept more easily. Again, at perihelion, as the swarm encountered the cloud, trajectory was altered further, and the asteroid swarm's orbital plane progressively flattened as it was flung back toward aphelion. And so over the years, each asteroid swarm's initial inclination angles were reduced toward Earth's orbital plane. This is why today we observed a distinct asteroid belt rather than a spherical shell. From a polar view of the solar system, we can see how the combined effects of the solar wind and the debris cloud affected the asteroid orbits as they cycled in and out of the inner solar system. Elliptical orbits gradually expanded and became circular as these forces acted. As expected, the cloud of gases and debris near Earth itself had dissipated in the presence of the solar wind, so that today, after thousands of years, only a faint signature of interstellar dust remains. But how did the larger asteroids get all the way out beyond Neptune? To the casual observer, this probably seems impossible, so let me take a minute to explain. Whether an asteroid remained in the belt or continued to spiral away from the Sun was a function of the swarm's initial collective mass, which determined the amount of gases they could potentially collect and retain. Just beyond the asteroid belt, a tipping point was reached which distinguished asteroids from TNOs. Near the Sun, smaller swarms had a smaller sphere of influence and less gravitational pull, so they collected fewer gases and more easily lost the gases they did have to the Sun's rays. Once these smaller swarms lost their gases as they spiraled away from the Sun, they essentially lost their solar sails, and the solar wind had little effect on changing their trajectory, so these swarms ran out of steam in the asteroid belt region and became asteroids. Larger swarms with more mass had greater gravitational spheres of influence, so they were able to attract more surrounding material. A larger swarm's greater mass meant it was harder for the Sun's rays to impart the energy for the gases to reach escape velocities, so larger swarms held on to their surrounding gases. As each swarm spiraled farther away from the Sun, its gases cooled, so the gas was less likely to escape. So the swarm retained its solar sail and continued to spiral further and further away. So for these larger swarms, the Sun's energy could continue to act upon the swarm's still present gas, quote, sails, and pushed the swarm further and further away from the Sun. Since the time of the flood, these swarms have slowly spiraled out to their present orbits to become the TNOs of what is known as the Kuiper Belt. Because the swarms slowly spiraled out from the inner solar system, there was increased chance that some TNOs' orbits were perturbed by gravity as the giant outer planets passed by. This is why some TNOs' orbits are found to resonate with Neptune's orbit. This is only explained if the TNOs were once much closer to Neptune, as hydroplate theory proposes. The hydroplate theory of formation also readily explains why many TNOs, like asteroids, have moons, and why some pairs of TNOs of similar size have come to orbit each other as wide binaries. Wide binaries are pairs of TNOs of similar size that orbit each other, but at such great distances that their capture of one another is not easily explained. Professor Jean-Luc Margot explains the problem. Binary systems, two objects of similar size orbiting each other, are astronomical treasures for both the observer and the theorist. Their very existence raises perplexing questions about their formation, stability, and evolution. 7 such objects have now been identified in the Kuiper Belt. Such wide separations between are truly arresting and defy accepted ideas about the process of binary formation. How did such a system form? Why does it have such large orbital separation and angular momentum? Hydroplate theory's proposed theory of TNO formation again readily provides a mechanism for these strange wide binaries. Capture began during the flood, in the inner solar system when the bodies were much closer together. First, if the mass and size of the nearby TNO pairs differed greatly, and were within each other's sphere of influence, and a gaseous atmosphere was present, then aerobraking could occur and provide a means for the larger TNO to capture the smaller TNO as a moon. Or the smaller TNO may merge with the larger TNO. However, if a nearby pair were of similar size and mass, aerobraking would draw the TNO into tighter orbit and ensure that they remained within each other's sphere of influence. Similar size and mass of swarms would mean that they would each experience similar outward thrust from the Sun's energy, so neither would outpace the other as they spiraled out. As the pair traveled to the far reaches of the solar system, the gases between the two TNOs dissipated, yet with so little mass out in the far reaches, there was minuscule chance that any other object could dislodge the pair, so the two became trapped in each other's growing spheres of influence. This may explain how binary pairs form, but how did the distance between the pairs become so great? Remember that as swarms of spinning rocks orbited each other and gravitationally collapsed toward their combined center of gravity as they traveled out from the Sun, the combination of angular momentum of each swarm increased in keeping with the law of conservation of angular momentum. As a binary pair orbited each other, the more massive sides of each spinning TNO, represented here in orange, had more gravitational attraction to one another. This imbalance continually acted to reduce each TNO's rotational momentum over time. Again, in keeping with the law of angular momentum, This loss of rotational momentum was conserved and transferred to increase the angular momentum of the orbiting pair. So the pair naturally spun further and further away from one another. Eventually, the more massive ends of the TNOs oscillating relative to each other acted like pendulums until finally they became tidally locked, orbiting each other at seemingly impossible distances. The ejected sea of high-velocity debris, water, and gases from Earth during the flood also explains much of the Moon's surface topography we see today. The Moon is gravitationally locked so that only one side ever faces Earth. The smooth dark spots on the Earth side of the Moon were once thought to be seas, so were called maria. The dark maria are actually a remnant of a great deal of melted rock. The far side of the Moon is much different. While the Earth's side is relatively smooth, the far side is heavily cratered as though impacted by many small objects, primarily from debris kicked up by larger impacts on the Earth side of the Moon. Again, here is the view we always see from Earth, and here is the far side view that, while cratered, has no dark maria. While the Earth side is relatively smooth from the maria, the far side has been heavily cratered by many small impacts. The Earth itself tends to shield the Moon's near side from impacts. Did several asteroids impact the Moon while at the same time missing Earth? While not a complete impossibility, the expectation would be for large impacts to favor the far side of the Moon where it is not shielded by the Earth, or at least for impacts to be more evenly distributed about the Moon's surface. The far side of the Moon is always open to incoming impacts. We might imagine that with the Moon being so far away from the Earth that the Earth would be a poor shield for the Moon's near side. That is because we tend to think of shielding in terms of straight-line impacts, somewhat like seeking cover from bullets. So in this scenario, there seems to be many available angles where incoming objects could still strike the near side of the Moon. However, unlike bullets at short range, the large gravitational pull of the Earth greatly affects trajectory. The Earth's gravity makes striking the Moon's near side by first passing nearby the Earth much less likely than we may first imagine, even though the Moon is physically far from the Earth. The shielding effect of Earth's gravity becomes even more apparent when we remember the concept of gravity being a function of an object's mass, which stretches the fabric of space, making a gravitational well. When this concept of gravity is visualized, we can more easily see how unexpected it would be for an object rolling left to right on the gravitational well to strike the near side of the Moon. It is possible, but certainly a great deal less likely than striking the far side. Inbound objects moving right to left have a much better chance of striking the Moon's far side. What if the debris that struck the Moon's near side came from Earth? Gravity measurements of the Moon's surface confirm several areas of highly concentrated mass, likely due to very large objects that impacted from the direction of Earth. If these were random asteroids from space, why are they all concentrated on the Earth side of the Moon? How did several asteroids impact the Moon while at the same time missing Earth?
Assuming the Moon is billions of years old, researchers find that the Moon remains unexpectedly hot, measuring very high heat flux still emanating from its surface, and finding a small molten core.
In addition, the lunar prospector picked up signatures of the short-lived radioisotope radon-222, emanating near two craters on the Moon's leading face. How did radioactivity develop inside the Moon? Hydroplate theory proposes that the mass concentrations, the unexpected heat, the presence of radon-222 gas, the remnant water ice in craters, and the unique topography differences between the Moon's near side and far side are best explained as a result of a recent bombardment of the Moon during the flood as materials were launched from the Earth's deep fountains. Dr. Robert Brown, professor of astronautics at the United States Air Force Academy, calculates that the debris would have reached the Moon's sphere of influence outlined in yellow approximately 5 days after exiting Earth's atmosphere. Ejected debris then began impacting primarily on the leading face of the Moon's near side.
As discussed in the hydroplate overview and radioactivity presentations, the ejected materials would be expected to contain both water and many radioactive isotopes, some of which continue to decay into short-lived radon gas today. The recentness of this flood event explains why these short-lived materials are still detected on the Moon's surface. After millions of years, short-lived deposits of ice in these craters would have long since dissipated.
Hydroplate theory also explains why the far side of the Moon does not have mass concentrations, or mass cons, nor the dark maria that we see on the Earth side. The far side was sheltered from direct impact. However, smaller, lower velocity debris lifted from the surfaces of the near side's direct heavy impacts could not escape the Moon's gravitational sphere of influence, which pulled it back. This produced many secondary impact craters all around the Moon's surface. These secondary impacts would have struck the near side of the Moon as well. However, since the Maria basins remained hot and volcanically active for a time after the initial impactors hit, many of the secondary impacts on the near side were absorbed and quickly resurfaced, while the cold, inactive far side's surface preserved the many craters. The added mass from these impacts would have changed the Moon's orbital characteristics from what they were in the past. History shows that ancient calendars held that a month was once 30 days rather than the 29.53-day lunar month today. Many ancient cultures held to a 360-day year as well. References in Vedic and Sanskrit works explain that the year and month changed due to great upheaval in the past. Genesis 1:14-18 indicates that the original purpose of the Moon was for telling time. The flood account in Genesis 7 also indicates that before the flood, months were exactly 30 days. We'll not cover it here, but I explain how the flood changed the year to 365 days in Part 6 of the Hydroplate Overview series. The added mass from these impacts on the Moon would have changed the Moon's orbital characteristics. If the Earth had originally had a 360-day year and the Moon originally had a perfectly circular orbit with a 30-day period, then this system would have made for an excellent method for observing time. Assuming this perfect orbital condition to be the original orbit of the Moon, Professor Robert Brown has shown that if only 1.22% of the estimated mass of debris launched during the flood were captured in the Moon's sphere of influence and eventually struck the Moon, it would have reduced the Moon's angular momentum, dropping the Moon into a lower orbit, and the lunar period would have decreased to what we observe today. In fact, analysis of this proposed scenario of added mass shows that the resulting calculated perturbations of 7 orbital parameters of the Earth-Moon system match almost exactly with what is observed today. Note that there is only a fraction of a percent of error between the actual observed values of the Moon today versus these calculated parameters. This information, taken in conjunction with the many ancient historical writings that suggest there used to be a 30-day lunar month, make for a compelling argument that the initial created condition of the pre-flood Earth-Moon system was indeed a very good system for measuring time, as indicated in Genesis 1:14. The full analysis and derivation of these results may be reviewed at the link shown here. Sometimes people ask, if comets are really from Earth, couldn't you just calculate orbits of all the comets backward from today and then see them all converge near the Earth at the same time of the flood? Unfortunately, comet orbits are changed to varying degrees when they pass near a planet. The closer the pass and the more massive the planet, the greater the change. If a comet, 1, seldom comes near a planet because its orbit takes it far from the planets most of the time, and 2, has been observed many times in the past 2,000 years, so its orbital path is reasonably well known, and 3, powerful computer programs have projected it and all the planets back 4,000 to 6,000 years ago to try to calculate how these inevitable perturbations have altered the orbits, then we should find these comets near the Earth at about the same time the flood began. So in spite of these challenges, however, 2 comets best fit these requirements, Comet Swift-Tuttle and the most well-known comet, Halley's Comet.
Perihelion for these 2 comets is very close to Earth's orbit. However, as you can see, rarely will they both be close to the Earth at the same time. Using the many historical observations of these 2 comets does allow us to analyze statistically when each would have been near Earth at perihelion, by projecting their periods back in time. The statistical approach of analysis also allows us to keep track of the total error in our conclusions. So does this method result in showing these 2 comets and Earth, all 3 bodies, once occupied the same relatively tiny volume of space? If so, is that just a coincidence? This graph plots the closeness in days that the 2 comets would pass perihelion near Earth's orbit as the analysis marches their earliest orbital periods back in time. So for example, 4,200 years ago, Halley's Comet and Swift-Tuttle's perihelion times were roughly 22,360 days, or about 61 years apart. 4,400 years ago, their perihelion separation was much closer, roughly 949 days, or about only 2.6 years apart. So as you can see in the zoomed-in area of the slide, from the time one comet passed perihelion, it was 2.6 years until the other comet passed its perihelion. This is closer than 61 years, but when we consider we are looking for an event that occurred within a few weeks or at most months, 2.6 years is actually a very loose clustering, with one of the comets being well outside Jupiter's orbit. Interestingly, continuing to go back in time, these two comets do not cluster significantly close to Earth at all. That is until you go back to around 5,300 years ago, or 3290 BC. Amazingly, the analysis, using the comet's earliest known periods based on the earliest observation, shows that inside of the year 3290 BC, both of these very clock-like comets passed perihelion near Earth within just 35 days of each other. At our current timescale of 2 seconds a year, it is hard to see and appreciate how close these three bodies were to each other in such a short period of time. To see this more clearly, we'll slow the animation so a year equals 24 seconds. Now at this much slower pace, we can see Comet Swift-Tuttle enter near Earth's orbit and pass its perihelion. Then within only 35 days, Halley's Comet passes perihelion. Of course, each comet's period would have changed slightly with each orbit due to gravitational perturbations from other large orbiting bodies like planets, just as is observed today, so there is some uncertainty as to the actual time that this occurred. However, the odds of a comet receiving a boost from another object are the same as the odds of the comet feeling a drag, so the error distribution is expected to be a normal bell-shaped curve. Again, the historical record of these comets passing by Earth gives a suitable sample of data that reveals how each comet's period changes over time, and this can be used to show the expected error in the 3290 BC mean date. Statistical analysis of these two comets results in a 1 sigma standard deviation of plus or minus 100 years from the mean date. As you can see, no matter where Earth was in its orbital path, this is still a fantastically close clustering of these three bodies in 3290 BC. But is this statistically significant, or just a random but very common occurrence? In other words, how often does a deep spike in the data similar to this 35-day clustering occur? Well, statistically it turns out that if the orbits were just random, then we'd have to search forward or backward in time an average of 333,000 years in order to find a clustering event that was at least as close as the 35-day event that occurred 5,300 years ago. If this data were printed on 8 by 11 copy paper and you printed out 2,000 years of data on each page, you would have to print out 176 pages of data before you found another spike in the data that was as deep. Or another way to visualize the rareness of this event would be to watch the opening slide of this section that was running at a rate of 4 years per second. We would have to watch the animation at this speed an average of just over 23 straight hours to see the tight clustering occur again. So a very unusual and rare event indeed. Statistically, it is unlikely that this is simply a coincidence. Considering all we've just covered and running the clustering event forward in time roughly 5,300 years ago, we see that the more likely scenario is that during the first weeks or months of the flood, clusters of material that eventually formed into these two comets, and all other comets for that matter, were launched during separate powerful pulse events from the fluttering crust of the Earth. Follow this link for more information on this statistical analysis methodology and how the Greek Septuagint translation of the Old Testament genealogies comes surprisingly close to matching the time of Noah and the flood to this astronomical data. This concludes our sidebar discussion of hydroplate theory's explanation for the formation of comets, asteroids, and TNOs.
This concludes. And again, Dr. Galusa didn't want to watch that. That was the plan, is to finish with that. He didn't want to because he was already convinced by the earlier presentation of all the evidence. And, and he figured his guys could go and watch that anytime they wanted to, and he just wanted them to get a bigger overview of the hydroplate theory, and which is why we did part 1 and 2 instead. So, Ray?
Can I assume that everything isn't going in the same something's going to crash into somebody really fast, it's going to be going the other direction. It's going the same direction as the home. You know what I'm saying? Look at asteroids and the comets.
Okay, almost all the asteroids are in the asteroid belt going the same direction as the Earth around the sun, for the reasons he was talking about. They were just shot out with a little bit of energy. Let me put it, this is the way to answer the question, I think. When we launch, just a second here, when we launch a spacecraft from Florida, why does everybody launch as close as they can to the equator? When you're standing on the equator, how fast are you moving? 1,000 miles an hour. You don't feel it, but you're moving 1,000 miles an hour. If you're on the North Pole, how fast are you moving? 0 miles an hour. You're just going, around like that. So the centrifugal force of the Earth is greater at the equator. And so why do we always launch spacecraft going in the direction that the Earth is going? Because you're taking advantage of that 1,000 miles an hour. Because now you didn't have to use rocket fuel to get it going 1,000 miles an hour if you're on the equator. Florida is as far south as you can get. I don't know what the speed of Florida is, but it's less than 1,000 miles an hour. But you're using that speed so that you don't have to put that into the rocket to get it to go around. See what I'm saying, hopefully? So things that are just lightly ejected from the Earth are going to come back down if they're launched retrograde, like if they're just going out in the direction opposite because of the spin, then they're going to not get into orbit. The stuff that's going in the direction, like the crack, some of the crack is not going as fast as other parts of the crack, so it's just going to go up and stuff's going to come down. The stuff that just escapes the Earth, it's going to be going prograde. It's going to go prograde, meaning it's going in the same direction as the Earth, and that's why almost all the asteroids are going in the asteroid belt are prograde. And as it was explained earlier, comets, the same thing. Short period comets, ones that are just ejected with less energy from the Earth, they're almost all of them are prograde because they took advantage of that velocity of the Earth when it was ejected. Father, we thank you for this time, and we just pray that you would just help us, God, to minister and to help Randy Galus and Dr. Galus. In Jesus' name, amen. As a closing comment, I want to just thank you for taking the time to investigate along with us the origin of comets, asteroids, and TNOs, and leave you with just one more powerful thought. And that is, if this is how comets and asteroids and TNOs came about, by the jettisoning of material from the Earth that then came together into these bodies as we've spent these 3 hours discussing. If that's what happened, then it's completely solves the problem of what does it mean when the fountains of the great deep burst up and the windows of heaven were open. It is water and debris from Earth that came out from the subterranean chambers with enough energy to escape Earth's velocity and to go into space. And what that means is that there was this cataclysmic flood that the Bible described that was by water from underneath. And it also means catastrophic plate tectonic theory, or the canopy theory, or any other theory. It's been a theory that's been disproved if this is the truth. And all the evidence, as I've tried to emphasize, all the evidence is that the truth of where these objects came from, not creation, but by the fountains of the great deep bursting up about 5,000 years ago, as Dr. Brown has described in his chapter. And I hope you'll give that consideration as we as Christians want to pursue the truth and have a witness and an answer for the hope that's within us from the book of Genesis. God bless you, and thank you for taking the time to watch this video.
Ooh, you're glorious, yeah. Is your name